After completing this lesson, you can do objectives, understand the concept of computer programming language, learn about making algorithm and flowchart, understand about the categories of computer language, understand the meaning and examples of language. Processor. Dear friends, you all know that to communicate with each other, you need some languages. Similarly, to communicate with a computer, you need a computer language. Let us learn about it. Introduction of programming. Humans can understand a variety of spoken language. English, Hindi, Punjab, etc. Whereas computers understand only one language. This is the machine language. Let us understand it in following manner. If someone asks you to add 8 plus 5, you will quickly add and give the answer 13. But if the same question is asked to the computer, it will not be able to answer this. This is because your variable instruction is not understood by the computer. It can only understand the instructions given in the computer language. The set of instructions written in a language which a computer can understand is called a program. Whenever you have to solve any problem or any work to do, you have to follow a step-by-step procedure so that you can get the desired outcome. In the same way, a computer also carries out its function in a step-by-step procedure to give accurate results. Basically, a computer program involves 3 steps. First, algorithm, creating an algorithm. Second, flowchart, making a flowchart. Third, program, converting a flowchart into a program. Algorithm. An algorithm is a step-by-step producer to carry out any particular task, such as mathematical or a logical problem. Let us understand it by an example. What steps would you follow to buy a shirt? The possible steps are as follows. Step 1. Take money and go to the garments shop in the market. Step 2. Tell the shopkeeper which color and style of shirt you want. Step 3. Choose and finalize the desired shirt. Step 4. Pay money to the shopkeeper. Step 5. Take the balance amount, if any, from the shopkeeper. Finally, you get the desired result, I.E. a new shirt. One more example of algorithm. Algorithm to add any two number. Step 1. Start. Step 2. Take two numbers. Step 3. Add the numbers. Step 4. Print the result. Step 5. Stop. Flow chart. A flowchart is a dramatic representation of problem-solving processes I.E. algorithm. It is called a flowchart as it charts the flow of a program. The direction of flow in a flowchart is always from the top to bottom or left to right. Hermann Goldstein and John Moore Newman developed the flowchart, originally a diagram in 1946 to plan computer programs. In a flowchart, each operation is represented using specific geometrical symbols. The symbols are connected to each other by arrows to show the operation. Following are some basic symbols that are used while making a flow chart. Start stop box. It's an oval shaped. It is an oval shaped symbol used at beginning and at the end of the flow chart. It shows that starting and ending of a flow chart. Input-output box. It is a parallelogram shaped box. It is used to indicate an input-output program. I.E. the instruction related to input getting the result. Processing box. It is a rectangular shaped box that is used to show the processing part of flowchart like calculation. Decision box. It is a ramus shaped box that is used to check the conditions displayed, comparisons, and take the decision to solve the problems. Flow lines. These are the arrow lines used to connect the different shapes of the logic in a flow chart. Connector. It is a circle-shaped symbol that is used to parts of the flow chart. Advantage of flowchart. First, flowchart helps in solving a problem or carry out procedure in one more systematic way. Second, it is a better way of communicating the logic of a system. It acts as a guide during the program development phase. Fourth, it helps in finding out errors. Disadvantages of flowchart. Sometimes the flowchart becomes complex if the program logic is long. If you want to change something in the flowchart, you have to redraw it all over again. Rules for making a flowchart. These are the rules that should be followed while a flowchart. The flowchart should be clear, neat, and easy to follow. Only one flow line should be used in conjunctions with a terminal symbol. The direction of a flow in the flowchart should be from top to bottom or left to right. Avoid the intersections of flow lines if you want to make it more effective and clear. If the flowchart becomes complex, it is better to use connector symbol to reduce it. Converting an algorithm into flow for adding two numbers. Algorithm. Step 1 start. Step 2 take two numbers. Step 3 add the numbers. Step 4 print and the result. Step 5 stop. Flowchart start. Input n1 n2. Sum equals to n1 plus n2. Print sum and stop. Start the beginning of flowchart. Input give two numbers to computer. Input give two numbers to computer. Processing give instructions to calculate. Output the result is displayed. Stop the end of flowchart. Program. Normally, an algorithm is first represented as a flowchart, and the flowchart is then expressed in a programming language to prepare a computer program. Preparing a computer program is the last step in solving a problem, which is written the computer language to get the desired results. Let us study about it. Computer language. A computer understands the instructions given to it in its language, that is machine language. This language used binary digits 0 and 1, but it used difficult from the programmers to write their program directly in these digits. Therefore, other computer languages have been developed in which writing programs have become easier. A computer language, also known as programming language, is a special language understood by the computers and consists of a set of four symbols and codes that is used to write a computer program. A program is a set of instructions given to a computer to get a particular task done. The process of writing a program is called programming. The people who write programs are called programmers. However, a computer cannot understand these languages directly, so some special softwares programs have also been developed by translate the programs written in other languages into machine language. Categories of computer languages. There are a number of computer languages available nowadays. Computer languages are classified into two major categories. Machine language, first generation language, 1GL. Assembly language, second generation language, 2GL. Low level languages. High level languages. Procedural language, third generation language, 3GL. Second, non-procedural language, fourth generation language, 4GL. Third, natural language, fifth generation language, FGL. Low level language, LLL. Low level languages are written to run on a particular computer and hence they cannot be easily used on other computers. Two main categories of low-level languages are machine language, assembly language. Machine language. A machine language, also called first generation language, is a language directly understood by a computer without any translations. It refers to zeros and firsts that a computer can understand as instructions. Due to its reason, it is also called low-level language, short form LL. Triple L. Limitations: machine language. Machine language programs run only on the computer for which they have been developed. I.E. They are machine dependent. Machine language programs are not portable to other computers. Assembly language. Assembly language, also called second generation language, is also a low-level programming language. An assembly language uses letters, symbols instead of using numbers, firsts and zeros. A programming written in assembly language uses short sequence of letters called mnemonic codes like ADD for addition, CMP for compression, LDA for loading, and MUL for multiplying. Assembly language programming is a source programming which must be translated into machine language before computer can understand it. An assembler is program used to translate assembly language into machine language so that the computer can understand. High-level language. A high-level language, HLL, has instructions which are almost similar to English language. It is user-friendly and resembles the language that we use. It is easier to understand and write a program in this language. HLL is a machine-independent program written in HLL high-level language can be run on almost all the computers without any change. Interpreter and compiler are the two programs used to translate high-level language into machine language so that the computer can understand it. Their main categories of high-level language are producer language. A procedural language is also called the third generation language, 3GL. In this language, the programmer writes instructions that tell the computer what to accomplish and how to do it. This language uses English like words like ADD for addition or print to print. To make it easy for programmer to write a program, many third generation languages are also use arithmetic operators such as multiplication and addition. The 3GL is also called the source programmer, which must be translated into machine language before the computer can understand it. The compiler is the interpreter is used to perform the translation for the third generation language. C Basic, COBOL, and Fortran. Non-procedural language. A non-procedural language is also called the fourth generation language, 4GL. In this language, the programmer only specifies what the program should accomplish without explaining how it uses English like statements. In fact, 4GLs are so easy to make the users with very little programming knowledge can also develop programs easily. It is also the source program which must be translated into machine's language with the help of a compiler or an interpreter. Usual, Basic, Java, etc. are the example of 4GL. Natural language. A natural language, sometimes called the fifth generation language, FGL, in a type of query language that allows that user into request that resembles human speech. Natural languages are often associated with expert system and artificial intelligence. These systems are popular in the medical field. Language processor. Language processor. A language processor is a software that converts source programs into machine languages because a computer does not understand the program written in LLL. Assemblies language is understand only machine language compiler, the interpreter, that examples of the language processor. Compiler. A compiler converts the entire HLL program into machine language at once and also displays errors for the whole program together. Interpreter. Interpreter converts one line of program at a time. It displays error of one line at a time and goes to the next line only after correction of the error.